Hello everyone. In this video we'll go through two exercises of how to calculate the soil volumes in different states. So the first exercise here, we have a sand in its natural bank state has a density of 2600 kilograms per meter cube. It's required to hold the excavated sand from a 10 by 10 by 10 meter excavation pit using 10 cubic meter capacity trucks. If the sand loose density is 2260 kilogram per meter cube, how many truckloads are needed to hold the required 1000 meter cube sand? So when we read the problem, we see here that the sand has a bank density of 2600 kilogram per meter cube. We can also see that it has a bank volume of 10 by 10 by 10, which is end up with 1000 cubic meter. But we learned in the lecture that we need to differentiate that quantity by saying it's not meter cube, it's actually bank cubic meter. So it's not like any other cubic meter, it's a bank cubic meter. Continue reading. We see here that the truckload is 10 meter cube, and again trucks are loaded with loose soil, so we can cross this unit and say it's a loose cubic meter. Continue reading. We see that also loose density is given to us as 2260 kilogram per meter cube. So always a practice, summarize the problem and the given values to you at the beginning of the problem before solving it or even planning its solution. Now what's required here is how many truckloads are needed to hold that 1000 cubic meters, or we here know they are bank cubic meters. Now truckloads, we can calculate these as the total loose volume divided by one truckload, which is also n loose cubic meters. So the whole idea is to calculate now the total loose volume. The total loose volume, this means that we need to translate from the total bank volume, which is 1000, to a total loose volume. So the relationship here we can represent it using the swell percentage factor, which is given here as this formula: bank density over loose density minus 1 times 1%. And then if we just apply the values given to us, this will give us 15% swell percentage. This means that we can calculate now the total loose volume based on the bank volume and the swell percentage we calculated. So that means that this 1000 bank cubic meter will swell to be 1150 loose cubic meters. Another way to calculate the loose volume is to use the load factor. The load factor formula from the lectures, you remember, it's loose density over the bank density. Plugging in the values, this will give us 0.86923. Using now this relation to relate the loose to the bank volumes, using that load factor, using these two values, we'll end up with the same total loose volume, 1150. Either way will give you this VL, loose volume. So now we have VL, total loose volume, divided by the truckload. That will give us 115 truckloads, and that will be the end of this problem or this exercise. Moving to the second exercise. A contractor needs to supply the sand required to compact soil layer under a building raft. The layer area is 1000 meters square and has a 20 centimeter thickness. The supplied sand has a bank density of 2600 kilogram per meter cube, and it is required to compact it to a density of 2850 kilogram per meter cube. How many bank cubic meters BCM of sand needed to be supplied. So reading through the problem again and summarizing it, we see here that the volume is given to us as compacted volume, which is an area of 1000 and a thickness of 0.2 meters. That gives us 200 meter cube. But we know that's a volume in a compacted state, so I will cross meter cube and say it's a compacted cubic meter. Keep reading. We see here that is given to us also the bank density of 2600 and a compacted density of 2850. Continue reading. Now we see the problem is asking for the bank volume. So this problem or exercise is relating the compacted volume to a bank volume. So the bank volume, we can relate it to the compacted volume by the shrinkage percentage. The shrinkage percentage can be calculated using the densities given to us, the bank density and compacted density, using this formula here. Just plug in the values and you end up with 8.77% shrinkage percentage. So you can now plug in the formula of the bank and compacted relationship, 200 compacted cubic meter over 1 minus 0.0877. This means that your bank volume needed for that 200 compacted cubic meter is only 219.23 bank cubic meter. It's not a big difference, but because this is a small quantity, you will not see a big difference, but in large quantities it will be really significant. Another way of solving this exercise is using the shrinkage factor, so not the shrinkage percentage. So the shrinkage factor, now you can say VB is equal to VC divided by the shrinkage factor. Shrinkage factor is a relationship between bank and compacted density. Once you plug in the values, you end up with 0.9123, and then plug in this value to relate VB and VC, you end up with the same answer, 219.23 bank cubic meter. I hope these exercises were helpful for you to understand the relationship between the volumes of the soil at different states, and how to use the swelling and the shrinkage factors in your for your benefit in dealing with these type of calculations. I hope it was helpful again, and have a good day. Thank you.